Okay, polynomial mini project. So I'm going to show an example of what your polynomial mini project could look like. Obviously, don't copy my example. I'm just showing you sort of how to do the math. All right, so step one, create a polynomial in factor form by choosing any two factors. So I can literally put whatever two factors I want here. Now I'm going to be lazy and pick easy things, x plus 1 and x plus 2. I just picked two numbers, 1 and 2. Done, easy. Okay, leading coefficient's 2, so make sure I pay attention to that. Now I got to change this so it's a double root. Now to make it a double root, I just pick one of these factors and change it to squared. There, now it's a double root. Look, I already got the first 3 steps done, and that took me less than a minute. So that's done. Now this is the part you might need help with. Convert this to standard form using multiplication. Okay, so I've got 2 parentheses x plus 1 squared times x plus 2. All right, so I'm going to start with this x plus 1 squared. That is the same as x plus 1 times x plus 1. So I'm ignoring all the rest of this thing for now. I'm just going to do x plus 1 times x plus 1 using the box. So x1, that becomes x squared, 1x, 1x1. Got some like terms right here, so I'm going to combine those. So this thing just turned into x squared plus, I'm going to add these like terms, gives me 2x, plus 1. Now, that was just basically this expression is basically me rewriting this part in the standard form or expanded form. So you can see I haven't done anything with the x plus 2 or the 2. So put a parentheses around that because it's still 2 times this whole thing times this thing. Okay. Now I'm going to come back to that 2. I need to do x squared plus 2x plus 1 times x plus 2. So I need a box that's bigger because we got x and 2, there we go. Hey, there's 3 terms here. This is a trinomial. So I got to have 3 parts on this side of the box. All right, so x squared times x is just x cubed. X times 2x is 2x squared, and x times 1 is 1x. Then 2 times x squared is 2x squared. 2 times 2x is 4x. Okay, and 2 times 1 is 2. Hold on, let me close my email. Maybe. There you go. So you don't need to get my notifications of students doing their work. Okay, so before I do anything, I'm going to look at like terms in this. Like, hey, there's an x squared, there's an x squared, so there's some like terms. Can I change the color? Oh, I can. Okay. And then 1x and 4x, those are like terms. So I'm going to combine all these like terms. And I'm going to get x cubed. These two, 2x squared and 2x squared, combine to give me 4x squared. You can see the exponent didn't change. It's still x squared. And 4x and 1x becomes 5x. And 2 is all by itself. So x cubed, combine these to get 4x squared. 1x and 4x is 5x plus 2. Hey, and now I can finally come back to this 2 that I completely forgot about. And I'm just going to distribute that 2 to every single term. So 2 times x cubed is 2x cubed. 2 times 4x squared is 8x squared. And 2 times 5x is 10x. And 2 times 2 is 4. Okay. So, okay. All right, so there is my equation in standard form. Now, it says I have to use Desmos to sketch a graph of my equation and be sure to label all this good stuff. So I'm going to open Desmos. It is, let's see here, 2x cubed plus 8x squared. Oh, I forgot what the rest of it was. Oh, 10x and 4x. Plus 10x plus, not 4x, just 4. Right? Did I do it right? 10x and 4, 8x squared, 2x cubed. Okay. So there it is. Looks pretty good. I'm just going to do a real rough sketch of this. Real rough sketch of this. Rough. Oh boy, here we go. Wait, where did that other x-intercept? Let me look at it again. Oh, it's a -1, so bam-o. Looks like that. Okay. Oh boy, it's real rough. I told you it'd be rough. It's actually really rough. I'm gonna fix it. It's gonna look real nice. Okay, here we go. Bump. Bam. All right. Rough. All right, x-intercepts. Okay, so let's label. These are my x-intercepts because that's where it touches the x-axis. It doesn't have to actually cross it, just has to touch it. X-intercepts. Okay. And then I'm going to label my y-intercept. Hey, it's right here. There's my y-intercept where it crosses the y-axis. Check. Local maxes and mins. Okay, local max is basically like, look, let's say I had a graph like this where it's like, wee. The local maxes are just any of these places where it it's like the top of a roller coaster. I mean, imagine this polynomial graph is like a roller coaster. The tops, those are your local max. Local max. I bet you know what these things are right here, what these are called. Those are called your local min, because it's like the bottom of the roller coaster. Okay, so mine does have a local max. Well, let's pick green for that. Green, okay. So there is a local max. There's a top of the roller coaster, local max. And the local min's a little tricky because it actually is also this x-intercept, my local min. So there's my local min, local max. Oh, and even worse, this x-intercept is also the location of the double root. Double root. All right, rainbow pen. All right, so that is the front of it. I will post a second video that shows you how to do the back of it. But that's basically the front. So, you can pick whatever you want. Up here, when you pick yours, pick whatever you want. Pick small numbers. Don't pick like 9 and 3,000 or something bonkers like that. Pick some small numbers. Don't put 1 and 2. Those are mine. You can't use mine. You got to make up your own. But that's basically the front. Piece of cake. You can do it.